Well, hello, everyone. I think we'll go ahead and get started. Welcome to Crop Hour. This is Sunflower Week. Well, Sunflower and Pulse Crop Week, I should say. My name's Patrick Wagner. I'm the entomology field specialist for SDSU Extension. And today we'll be focusing on diseases of sunflowers and pulse crops. We have a couple different presenters today. We have an invited speaker, Dr. Febina Mathew. She's an associate professor at North Dakota State University. And then we also have Connie Strunk. She's our extension field specialist in plant pathology, and she's based in Sioux Falls. So if anybody has any questions, feel free to use that Q&A feature, or you can type your question into the chat box. And we'll address those at the end of the presentations. I also want to let everybody know that we'll be offering those CCA credits. So at the end of the talks today, I'll put up a QR code that you can scan and get that information. So I think we're going to go ahead and start off with Febina. If you want to get your slides going.
All right, can you see my slide?
I'm kind of just seeing like a black screen right now.
Black screen?
There we go. So it's on, there you go. It's on presenter view. Okay. So then perfect.
Perfect.
All right, so take it away, Febina.
Right, thank you, Pat. Thank you for giving me this opportunity to speak about sunflower diseases. Not necessarily just out of the areas where sunflower is commonly grown, which includes Minnesota and North Dakota, but also diseases that we have been seeing in the last several years in South Dakota and other states where sunflower might be produced in minors. So I am currently at North Dakota State University. I am an associate professor, and my crop responsibilities are broadleaf and oilseed crops, which also includes sunflowers. And typically, when we think about sunflower production, being in different states, it is one of the most important crops that is grown in the areas. In Minnesota, North Dakota, South Dakota, we're talking about 80% of the production. The planting dates do vary. The seeding rates tend to be the same. The hybrids might vary a little bit depending on the geographic region that you may be at. But what stays common when it comes to disease management strategies would be the use of fungicides, perhaps cultural practices, and host resistance. So ideally, I like to start my presentation by introducing what the growth stages for sunflower may be, because we, as researchers, tend to use a lot of code language, like we say V1 and R1 and R10, and sometimes it's not very clear what exactly we're talking about. So just like any other crop, sunflower plants, they go through 4 development stage when you consider from planting to harvest. In South Dakota, planting usually don't start until late May into mid-June. And we're talking about harvest anytime after the last week of September. So early October through Halloween is when I would have ideally harvested sunflower while I was in South Dakota. So we're looking at 4 phases. There's a vegetative phase, which I like to call seedling phase. A reproductive phase is when the bud starts to form and it slowly starts coming out of the plant. And then you have a period of ripening, and that's when the seed starts to set and the crop is sort of preparing for harvest. And then you have a natural senesce or dieback, and that's the time when the plant's just ready for harvest. So usually when we are out there determining if this is the right time to spray herbicides or insecticides or fungicides, we want to be able to take note of the growth stage. And how we do that is we just step into the field, perhaps identify maybe, I don't know, usually 5 or 6 corners of the field, take representative samples, assess the growth stage. You want to avoid areas where there are patches of uneven growth. And then we want to look to see how uniform they are across the field to determine the growth stage. So ideally, this would be like an early seedling stage when seeds has gone into the ground. It usually takes about a week or 10 days for the seeds to start germinating and coming out of the soil. And then as you go along, you get to see the vegetative stage. Ideal conditions right here to be able to spray herbicides, post-emergence, however, post-emergence herbicide until about the sunflower reaching 76 centimeter. And then when it comes to fungicide applications, we usually begin at this particular stage. I mean, this is what we call R1. Then when the floral head is sitting on the sunflower plant. And then R5 is usually when the flowers are in full bloom. I like to call it the selfie stage because that's one time when people are out there taking a lot of pictures. And so that is what we call R5. And then the sunflowers, they continue to bloom and then get into a stage where the seeds are being set in. And then this is like almost the end of the life. It's what we call the R9. So R7 to R9 is typically when we don't spray any sort of chemicals. We just allow the crop to naturally senesce until it's ready for harvest. So as for sunflower diseases, as I said in the beginning, Minnesota, North Dakota, South Dakota, we produce about 80% of the production in the United States. It's a major crop for us. Perhaps in the ranking, I would say between the Dakotas is usually corn, soybean, wheat, and then comes sunflowers. We've also got alfalfa. But it's a critical crop when you think about crop rotation with wheat, with broadleaf, other broadleaf and oilseed crops with corn and so on. There are two classes. You've got oilseed and confections. Oils is what we typically use for production of cooking oil. Confections is what we usually use for snacking, like in a baseball game or in salads. And these days, microgreens are getting very popular for health conscious folks. Between the two classes, oils are more popular. About 85% of the production for sunflower are mostly oils, and then confections tend to vary between like 10 to 15% on an annual basis. But the sunflowers are currently doing very well. It has been ranked as a profitable crop by USDA for a couple of years now. So it's I would think one of the best crops to be considering to cultivate in terms of market prices. On the right side, what I have is data from the National Sunflower Association survey that gets conducted once in 2 years. The color code that is against the Dakotas are essentially the fields that have been surveyed as part of their annual survey. And you can see in South Dakota, a lot of the production is pretty much concentrated in the central part of the state. There used to be a lot of production along I-29, but a lot of that got pushed to the western half. But as you see from North Dakota, as we go towards Texas, the number of fields are actually going down, and that's just because the acreage goes down. But although we have the bulk of the production here in the United States, one thing to notice is that the weather conditions are different. When we talk about Dakotas, it tends to be a lot wetter and cooler as compared to like Texas, where it tends to be dry and hot. And why that is important is because those weather conditions are what dictates the type of diseases that we might see. Also, although in the last few years there has been few diseases that I have seen in South Dakota that we don't usually see otherwise. So few diseases that we have seen here in South Dakota, downy mildew was a problem when the conditions tend to be wetter and cooler, particularly early in the season when sunflowers are planted. PHOMA black stem has been probably the more prevalent of the diseases. And I'm going to talk about these diseases in a little bit with a lot of pictures. And then there is Phomopsis stem canker that has been a problem since 2010. Rust tends to show up occasionally in South Dakota, although I don't know of reports where there has been a field that has been completely taken down by rust. It's a bigger problem here in Minnesota, North Dakota. And then we occasionally tend to see Sclerotinia diseases, head rot being one. But again, it really depends on the timing of rain when the heads are in full bloom. Among the dry hardy diseases, we tend to see rust again, Rhizopus head rot and verticillium wilt are more common down south. But in the last 8 years I've spent in South Dakota, we used to occasionally run into fields where we saw Rhizopus head rot or verticillium wilt. And so is it a problem perhaps in an isolated field? It is a problem, but we don't have currently any management options that can help manage these diseases. Fungicides are not working, and neither is the fact that the resistance is strong. So for today's presentation, I decided to focus on diseases that I have seen in South Dakota in the last 8 years. I used to be out there doing a lot of the NSA survey, which again used to happen once in 2 years. And there is a lot of data for these. But among the diseases which has been significant and yield limiting is the Phomopsis stem canker. And if you notice, all the other diseases have got just one fungi, but Phomopsis is a little unique because it's got several species that can cause the disease. And what I mean by several species means they're all different members of the Phomopsis family. So with Phomopsis stem canker, the symptoms are typically seen when the sunflowers enter the reproductive growth stages. So this is the time phase when the sunflowers are past the seedling stage, when you can see some sort of a floral head sitting on the plant. And usually the symptoms begin on the leaves. This is a lesion that is starting to develop right on the tip of the leaf. And then you can see the fungus. What happens over time is it starts to spread through the petiole to reach the stem and cause this characteristic brown colored lesion that is on the stem. It takes about 25 days to basically see the symptoms spreading from the leaves to the stem. But it is so, one thing to note is that when you see these symptoms on the leaf, it's a little harder to tell whether it is Phomopsis or not at that time, because there are several diseases that can cause similar symptoms. And we usually tell the disease apart by looking at the symptoms on the stem. So this is a field that I had in Brookings, just north of the campus. I have a Phomopsis nursery. And anytime I've planted susceptible hybrids, I get to see it totally hammered by Phomopsis. You can see the ground is very wet. So one of the factors that is driving disease development is rain. So if the field has a history of Phomopsis and rain is happening during this reproductive phases, we tend to see Phomopsis being a problem on sunflowers. So ideally, when we plant in June, the time to look out for Phomopsis stem canker would be sometime in August. And that's when the sunflowers enter the R1 stage and sits for at least 3 to 4 weeks till it reaches the full bloom. This is another picture from University of Nebraska. So you can see there is a difference in the head size. The ones with the smaller head size that is on the left is the one that was harvested from plants affected by Phomopsis stem canker. So the head diameter and the weight tends to be much lower than the normal sized head, which is on the right side. So for those of you that is on Zoom, I have a quick, I don't know if this is interactive, but I don't know if anyone can indicate to me which one is Phomopsis. So I have 3 pictures here for the stem. They look pretty alike. On the extreme left is this lesion that looks very black in color, but sometimes is very dark brown. And then the center one is where you have more of a lighter brown colored lesion, and then you have a more bleached out version. The bleached out is Sclerotinia stalk rot. We tend to see it again when the conditions are very moist. The center portion is the Phomopsis stem canker. That's the lighter brown. And then you have the black colored lesion, which is the former black stem. Sometimes it is hard to tell them apart because there are times when these diseases can appear one over the other on a single plant. So sometimes, which means it's a complex of disease that might be affecting the field. So Phomopsis stem canker, it was first reported in the United States in 1980s. For 16 years, there was really nothing much happening from Phomopsis fungi, but suddenly epidemic happens in 2010, and few fields, including industry nurseries in Minnesota, North Dakota, and South Dakota were affected. And from this research, we identified multiple species of diapolti can cause disease, which means multiple fungi can cause disease. So with funding from the National Sunflower Association, South Dakota Oilseed Council, and the USDA, what we immediately took on in order to identify strategies that can help manage sunflower diseases was to evaluate foliar fungicides that were already labeled on sunflowers, not necessarily against Phomopsis, but might be an option for other diseases. So we looked at two things. One is the application timing, another was the active ingredients. We conducted field trials for a total of 79 location years in 4 states, Minnesota, North Dakota, Nebraska, and South Dakota. And we followed pretty much uniform protocol. These are research plots. They're about 30 feet long, 10 feet wide, 30-inch row spacing. And depending on logistics, availability of the seeds, we chose between oils or confections. We also use different types of hybrids, susceptible to moderately susceptible, or what we call partially resistant hybrid. The seeding rate varied, again, dependent on the seeds that were available, but it was anywhere between 18,000 to 22,000 seeds per acre. And evaluations were done under natural disease pressure, which means we picked up sites where we know Phomopsis was a problem in the last 5 years. So at this time, there are 3 fungicide families labeled on sunflowers. We like to call it crack 11, the Q or I, or what I say, the headline family. We have crack 3, it's the triazole, which is also the follicule family. And then we have crack 7, SDHI, which is the Enterer family. Now, these 3 chemistries are very different. They have their own mode of action. They have different mobility properties, and also the ability to persist in the crop kind of tends to vary across the 3 chemistries. The number of fungicide treatments varied, again depending on the control. And then we included a non-treated control where no fungicides were sprayed. And we used a ground application. So either a backpack sprayer, so this is a carbon dioxide powered sprayer, and we used a flat pan nozzle. So the fungicides just were sprayed through the nozzle in such a way that each of the plant was covered. But also we used a high boy sprayer that also had flat pan nozzles, and we made sure that each of the rows of the plots were covered. So when we use a backpack sprayer, although we're talking about 4-row plots, it's usually the middle 2 rows that got the maximum coverage. But for the high boy, we made sure that all the 4 rows were covered. We were targeting multiple growth stages. So we tried the early vegetative stage, what we call V8. We also did an R1 application, which is when the floral head sits on the plant, and then R5, which is when the flowers are in full bloom. So during the season, fungicides were sprayed, and then we decided to evaluate fungicides based off disease severity and yield data that we obtained at the end of the season. So this looks a little heavy on statistics, but what I like to draw your attention pretty much are the rows that are marked in asterisk. So in order to reduce the disease, we observed there are 2 timings that can work in our favor, and that would be R1, that is when the floral head sits on the plant, and then a sequential application. So we spray at R1 and then at R5. But when it came to yield, we were able to see there was a maximum economic benefit by just spraying at one growth stage, and that is at R1. For active ingredients, again, we are looking at those with the asterisks. So anything that contains the word strobin were the ones that were promising. So you could see azoxystrobin, pyraclostrobin, and then right here again pyraclostrobin, and then there's a pyraclostrobin. So those seems to be pretty effective against Phomopsis. Again, at yield, also we were checking to see if the same active ingredients that showed it can suppress disease can also bring in the yield benefit. But we found there were just select fungicides that contained pyraclostrobin that seems to be effective. So this is what it looks like. These are pictures from my trials and Brookings. A non-treated control, which means no fungicide went on to these plants. This was taken in August, the same time between the 2. And this plot where fungicide was not sprayed was taken down in August itself. So we hardly got like 700 pounds per acre out of this. But out of the plots where headline was sprayed, the headline contains pyraclostrobin, we were seeing at least a 1,500 pound per acre increase. So there was a huge difference between spraying fungicide and headline. And the headline was sprayed only once in this plot, but you could see the difference in what the plants look like. So the next question was that now that we are seeing some sort of a benefit from using fungicides, are we also seeing any economic benefit in using this. So between 200 and 2020, we pulled out the grain prices for sunflower from the National Sunflower Association's website. It ranged anywhere between like $7 to about $30. The net return was calculated based off the prices that we obtained from South Dakota retailers for headline, which is about $6 an acre. And we estimated the fungicide application cost for both ground and aerial. In our trials, we didn't use an aerial applicator because none of us had our program set for aerial application. So what we ended up doing was to include the cost for a wide range, so anywhere between $5.5 to $12 an acre. So what we are finding is that if a farmer were to spray a single application of headline fungicide against Phomopsis stem canker at R1 growth stage, the likelihood that he is going to go under loss is less than 0.35. You are going to be able to see a profit of up to $300 per acre, depending on whether you are planting in oils or confection sunflowers. So confection sunflowers are priced really high, so we could see a profit of about $300 per acre. But for oils, somewhere it is sitting around close to $100 an acre. So it really the fungicide cost is driven by the market price of sunflowers. But from the math that we did by taking grain prices for the last 20 years, we're seeing that farmers can see some sort of a profit by spraying this single application of pyrethrostrobin. In 22, with just one chemistry working, our next objective was to see if there was any other product that was available which would help manage Phomopsis stem canker. So we had trials set in 4 locations. We used pretty much the same logistics as how we did the previous trials. The only difference was the previous trials, we did spray just one adjuvant, which is a non-ionic surfactant. But from 22 onwards, we began to use a combination of non-ionic surfactant and crop oil. And again, the water volume was set at 15 gallons per acre across the trials. Disease severity and yield was again obtained at the end of the season. So the difference though is we used a different product called Luna Experience that was sprayed at V8. V8 is usually the target for herbicide applications, and we used what is off the label. But we also used combinations of Luna with headline, which we call the split application. So we were targeting either a single application of Luna, or if we were to supplement the headline application with Luna, if we were going to see any sort of yield benefit at the end of the season. So these were the growth stages that we targeted. So V8 is ideally when an herbicide application goes in. So we were trying to see if we could get a fungicide going at the same time. R1 is what we are recommending at this time for Phomopsis. R5 is typically when an insecticide application goes in, and so that's why we were experimenting with R5. So I'm only presenting the data from South Dakota. This was in 2022. So in Brookings, what we found was one application of headline at R1, followed by a single application of Luna Experience at R6. It gave us a 30% greater yield, which was significant. And so we are looking at a yield benefit of 300. So that's essentially what it's saying. So you can follow the A bar. The bar is taller, so it's sitting at a 3,000 pounds per acre, while the no fungicide control was somewhere in the 2,300 range. So it's a huge bump with the yield benefit. So we saw something similar even in Minnesota, North Dakota, and Nebraska, where the same fungicide trial was repeated. So we are thinking that there might be another product that might be helpful in the years to come, but we like to repeat the study in 23 and possibly in 24 again across the 4 locations to confirm that Luna Experience could be an additional fungicide that's effective against Phomopsis stem canker. Now switching gears from Phomopsis to rust. Rust is caused by Coccinia helianthi. This is a pretty hard disease to miss because this produces these brown cinnamon-colored spores, both on the underside as well as the upper side of the leaf. This is what it looks like. It's usually brown-colored spores are the detrimental ones because that is what causes the disease. But the years that I have spent in South Dakota, I have seen these brown spores turning black And the black spores, which we call teliospores, are usually the spores that the fungus uses to last long, but they don't necessarily participate in disease development. They're just hanging in there till they are able to get fresh sunflowers, maybe in years to come. So this is more pictures of rust leaf. Now, rust is a very common disease even in other crops like wheat. In South Dakota, we've got 3 wheat diseases. We've got the stripe rust, leaf rust, and stem rust. One of the things different between the wheat diseases and the sunflower disease is that wheat diseases, especially the stem rust, spores can be blowing in from Texas into the Dakotas, and they time it in such a way that wheat is just probably getting close to harvest, or it can infect. But in the case of sunflowers, there is no need for the spores to blow from the south. It could be that the spores might be hanging in there from a previous season, and then you plant sunflowers, those spores can actually infect the sunflowers. So the disease can just develop within the field as opposed to it coming from a completely different state. So I have just a side picture. Although these look like brown and circular, there is no bump on the plant. So this is unlikely that this is going to be rust. This is more of a septoria or alternaria leaf spot is what we call in sunflowers. I have a few more pictures. So rust, it doesn't just occur in the leaves. There's a lot of, you can see these spores on the head. It could be on the stem. And what it does is it starts reducing the yield to like 30 to 40% over time. So again, it's a rust project was taken up by NDSU in 2009-2010, where they determined that the disease threshold for rust management is 1% disease severity. So we're looking at checking to see how much disease is present on the upper 4 leaves of the plant. So if the severity is about 1%, we usually suggest that they spray fungicides before R5, or that is when the sunflowers are in full bloom. So any applications made after the sunflowers are in full bloom, what we call anytime after R6, R7, we were seeing that the plants were susceptible, which means the fungicides are not working. So this is again going back to headline at 6 ounce per acre. Pyraclostrobin seems to be effective. I just have some data here suggesting that a week before there seems to be a lower disease severity. That's 1.3% as opposed to 8.7% when no fungicides were sprayed. So this is again pictures from Carrington. This is the non-treated control on the left side. You can see the leaves are fully disseminated by the by rust spores, but on the right side the leaves look much cleaner, and the greens and they look far more green. The plants do at R5. So among the fungicide chemistries, currently QIs are definitely effective, but there are also triazoles that seems to be effective. So triazoles are primarily like Polycure or anything that ends for an active ingredient with azoles is what we call triazoles. Sclerotinia diseases, the years I've spent at South Dakota, it's been a problem in isolated fields, I must say, and I have seen them both on soybean and sunflowers. It does not infect wheat or corn, but besides it infecting broadleaf crops like soybean and sunflowers, they can also infect broadleaf weeds, and so they tend to be a problem. Once we know that the farm has a history of Sclerotinia from the past. So the conditions driving Sclerotinia diseases is very similar to Phomopsis stem canker. If there is rain, particularly when the sunflowers enter the adult stage, and the temperature tends to be down. So if cooler and wet conditions can actually promote Sclerotinia diseases. The easiest way to tell if the plant is affected by Sclerotinia is by looking for these black bodies, what we call sporotia. Then you would see it in any broadleaf crops, and those are one way to indicate that it's Sclerotinia. So on this particular picture, the sclerotia is on the outside, but sometimes when the infection is pretty heavy, you can see sclerotia even on the outside. I have a few more pictures. So unlike soybean, on sunflowers, the fungus can infect in 3 ways. It can infect through the roots, what we call the Sclerotinia wilt. So what it does is it weakens the root and then slowly start making, the sunflower plants like weak on knees. So then if there's any vent or over time, what happens is the plants begin to lodge. These are structures that are produced by the fungus. They look like mushrooms, but these mushrooms are from where the spores actually are released. And these spores can be picked up by the wind, and then they can travel at least a mile to infect any adjacent field. So if you have soybeans in the area, or you've got field peas, or dried beans, or anything but wheat or corn in the area, you can be assured that even although this might be in your sunflower field, these spores can attack the broadleaf crops that might be in the area. This is a picture of where the spore would have landed on the leaf. This is sort of a rare sight, like we haven't seen so much of this, but sometimes when the spore lands on the leaf, you could see this kind of lesions developing. This is more pictures, again, when that leaf became in contact with the stem. And then this is Sclerotinia stalk rot. So this is when the fungus has infected this middle portion of the plant. And the plant tends to be fairly brittle, and it just kind of crushes the plant. So if you hold it with your hand, you can actually crush it. And if you were to examine the interior, you would see a lot of those black bodies. So again, sometimes it's easy to tell the diseases apart when they are not on the same plant. So this is on the extreme right is what I have, the Sclerotinia wilt, when you compare that with Phomopsis stem canker or PHOMA black stem. This fungus is also known to infect the heads, and this is something I have seen maybe 1 or 2 years I was in South Dakota. Again, just maybe 10 plants out of the 100-some plants that were surveyed. What it does is it actually goes directly for the head, and the rest of the plant looks very green. Now, Sclerotinia diseases in sunflower, it has been extremely difficult to manage, and we don't have very good genetics at this time. That's because the resistance mechanism tends to be fairly complex. It's not one gene that is involved in disease resistance. We need multiple genes to control, and breeding in sunflower for such fungi tends to be very complex. But that's also the case when it comes to soybeans and other broadleaf crops like canola, dried beans, and so on. Fungicides have little or no effect, although we do have data from Carrington suggesting that there may be some efficacy of these fungicides when sprayed at R5 growth stage. But again, one of the things to keep in mind at the time when fungicides are sprayed at R5 is the coverage. Use of the right nozzle, calibrated use of the right nozzle tip, the spray calibration, everything will has some effect on how the fungicide would behave against Sclerotinia at R5. So as a result of that, it may not be necessarily the product, but more so that it's because it's a challenge to get the coverage good at that particular growth stage. We have not been able to see that the fungicide is doing something to protect the crop from Sclerotinia diseases. At this time, there's no fungicide that could work against the mid-stalk rot or root rot caused by Sclerotinia. The biologicals, also we don't have much data. The only biologicals that has been labeled against Sclerotinia is Sclerotinia militans. But the one of the downside of using biologicals is that it is the solution or the effectiveness that we see when compared to fungicide is a lot slower, and sometimes it can match up to the to how much the fungicide can help manage diseases. But the only catch is that because biologicals are also living organisms, it takes a longer time to establish, and sometimes it may not show that it is as effective as using a fungicide. But crop rotation is something we recommend, and one would definitely want to consider using corn and wheat because they are not hosts of Sclerotinia. Downy mildew, I have seen this disease probably twice in South Dakota. One was in my field, and that's just because we happened to plant sunflowers very early into the season. And this was taken right off in Brookings. The picture on the right side is a downy mildew affected plant. You can see it is short, it's stunted. The one on the left side is a healthy plant. And when you flip the leaves of the downy mildew affected plant, you see this gray colored mycelia. That is one way to tell that we have downy mildew in the field. So typically when we plant sunflowers, we get treated seeds, and the treated seeds usually contain some sort of fungicide to prevent the downy mildew from organism from infecting sunflowers. This is again a field in South Dakota. I was on my way to Pierre and I saw this small plant right at the entrance, and it is flowered. It's in the same growth stage as a lot of the sunflowers that are standing up there. So it appeared stunted just because of downy mildew. This is another close-up picture of the same plant. It looks. This is all telltale signs of downy mildew. So at this time, based off research again from NDSU, what we're suggesting is that farmers talk to the seed dealers and see what type of hybrids or seeds that they could buy, which has resistance to the downy mildew organism. Fungicide treatments are available. Usually what we tend to see for fungicide treatments might be metalaxyl, mefanaxine. We don't have much of a data on that. But if your seed treatment contains any one of the other chemistries, it's likely that you are going to see the downy mildew, that they are effective against downy mildew organism. I have a few pictures from the work that was done at NDSU in 2014, 2015. There are a few hybrids that containing PI16, PI13, PI15 that seems to be effective against the organism. A lot of these are already commercially available, but there are several that has lost its effectiveness against the downy mildew over the years. This is again in 2016, 2018. We're still seeing the same genetics holding up. So this would be a chat with the seed dealer to see what your options are. But I must say that in the years I've spent in South Dakota, maybe because it's been very dry, a lot of the planting happens in June. The soil tends to warm up, and which is a little difficult then for the downy mildew organism to start producing spores. It needs really waterlogged conditions for the organism to start producing spores and swimming towards the plants to infect. So this is a picture that was taken in 2013 in Fargo when I was a graduate student up here. And this particular row has got no plants grown, that they were severely affected by downy mildew. But you can see the other rows where the plants have come up, they were treated with seed treatments. So from that particular study that was done here in Fargo, the non-treated check, they had a 35% infected plants, but a lot of this oxythioprofilin, it seems to be effective at 2 rates against the downy mildew organism. So this is what has gained a lot of popularity. It's also called planatus, and the seeds treated with these seems to be effective against downy mildew. PHOMA black stem, this has been one of the more popular diseases in the last 8 years in South Dakota. I usually see this, but there has been a lot of questions on if this is really yield limiting. A study that was done in South Dakota from the 80s suggested that there could be yield losses up to 60%. But we have not seen that, although we see the disease, we don't necessarily know how much yield losses this disease can cause here in the United States. It doesn't matter if it's South Dakota or North Dakota. The fungus is PHOMA. It's very common. Yield losses are limited. And how we see this are these small black lesions, and they could be like multiple lesions on a single plant. We also see these leaf lesions that is caused by PHOMA, and that could be mistaken for Phomopsis. So typically we tend to wait for the nodes for the disease to spread to the stems, and then we try to tell them apart between PHOMA and Phomopsis. Occasionally you do see PHOMA and Phomopsis occurring on the same plant, but we have to. What we tend to do is we go by the color. So if it is really dark, then it's PHOMA. If it's a little more lighter colored, it's Phomopsis. But at times when they both sit on each other, it's hard to make out the color also. So these are again more pictures of Phomopsis. There's also one for PHOMA. There's also a picture there's also a plant right behind it that is affected with Sclerotinia. What we were trying to see was if the PHOMA lesions, if it actually can degrade anything inside the sunflower plant. But you can see that from the knife that was just used to chop off the lesions, it looked pretty clear from the outside. So that's one of the complications with this organism. We're not quite sure as to what they can do to the sunflowers as yet, but there's research underway here at NDSU. So again, between PHOMA and Phomopsis, we tend to go by color. The big difference is Phomopsis tends to spread all through the plant, So over time, what happens is the stem starts to become brittle and it can lodge. But PHOMA tends to be pretty much at the node. There was fungicide trials that was done here in North Dakota that looked at the efficacy of the fungicides. So they again used 3 different timings. And what they found was the growth stage R1 or a combination of V8 plus R1 seems to be pretty effective. Again, it's the headline. And so headline tends to work at the same growth stage as Phomopsis. But also an early application seems to be effective against the fungus. So this was done in multiple trials over multiple years. And so we saw that even 2 applications of headline can be effective against PHOMA. They also tried different chemistries to see if there's any other chemistry besides the QOIs that are working. And it seems like the SDHIs are promising. They've got boscalid that's also labeled against Sclerotinia that seems to be effective against PHOMA. So I have a few more data suggesting the same. This is with yield. It seems compared to non-treated control, anything that contains a QOI seems to be effective. So in summary, for sunflower diseases, there are several diseases of economic importance, but management options are fairly limited. Typically, we tell the farmers to check with the seed dealers what genetics is available for the diseases, but I also tell the farmers to monitor the diseases, what might have happened in the last 5 years. If Phomopsis has been a problem, you want to be talking to the seed dealer. If rust has been a problem, you want to be asking what genetic options you have. So that's one of the key things to check. It's also important to survey the field while the crop is in season, and so that for the next time when the sunflowers go into the ground, which is usually like once in 3 years, 4 years, we are better prepared. But crop rotation with non-hosts such as wheat and corn is definitely recommended. Weeds tend to be a problem. While sunflowers, they could be very good hosts of many of these organisms that I mentioned. So weed management is very critical if we have to bring down the disease levels in the field. At this time, fungicides are an option. We have studies in progress, and some of these are on the label, some of these are yet to be on the label, but this is what we are recommending at different growth stages. You can see the promising chemistry at this time are QOIs and also SDHI. For downy mildew, we don't have any fungicide that can work through foliar applications. We have to use seed treatments. And so tip of the day, usually when we used to monitor for diseases in my field trials, one of the things that we do was to look to see what was showing up on wild sunflowers in the ditches. So if the wild sunflower, for instance, has got rust or phomopsis, one can be assured that it's going to be on the farm also. So that's one telltale way of saying what diseases you're likely to expect during that growing season. With that, I have several people to thank for. Several of the folks at NDSU for the last 8 years, we did a lot of research on sunflowers. We're continuing to research on sunflowers here at NDSU. So I have several collaborators from NDSU that are with me on my current ongoing projects. I like to also give a big shout out to the chemical and seed companies, farmers who actually helped us build some of these trials, and also to the South Dakota Oilseed Council, the National Sunflower Association, and USDA for funding many of the projects that I mentioned today. And my partners, SDSU, University of Nebraska-Lincoln, and University of Minnesota. So thank you.
All right, thank you, Febina. And we do have a couple questions in the Q&A. So first question, what causes rust?
So rust is basically caused by a fungus in the, it's in the Puccinia family. So rust is the disease and rust is a fungus. So the rust fungus overwinters naturally in the field. It could overwinter on the residues, and in the conditions that drives rust development is all hot and humid conditions. So that's what causes rust. It's when we look at other crops like wheat or dry beans where rust is a problem, they're more or less, the wheat ones are definitely in the same family as sunflower rust, but they don't infect each other though.
Okay, and then the second question, are the majority of these diseases overwintered on the residue? And if so, how long of a rotation should be done in between?
Right. Thank you, Shay, for the question, and thank you, Johnny, for the question too. So many of these fungi that we talked about today just overwinter in the residues. And I know that many of the tillage practices tend to be anywhere between minimum till to no till. And as a result, there are a couple of options that one can do. One is to extend the rotation. So ideally, we tell farmers to have 3 to 4 years of rotation. So which means sunflower goes once in 3 years or 4 years. In between, you have wheat, corn, or potentially if you want to bring in a legume crop for the nitrogen factor, soil health, that is a possibility. Or if one wants to do like in 2 years or some, we do ask them to disc the residue. So you're breaking down the residues as much as possible so that the fungus that might be overwintering on the surface of the residues do not get a chance to infect the sunflowers. So that's what we recommend the farmers at this time for crop rotation.
Okay, great. So if you want to stop sharing your screen, and Evan, I think, do we have a poll for attendees? There we go. So that just kind of gives us a, an idea of, how well this, these topics and presentations and stuff are helping you if you're learning anything. So please, if you have some time to just fill out that poll real quick. And Connie, if you want to go ahead and get ready and get your screen shared, we'll switch over to you.